Hi there, what you see here is a Roberts MP-43 radio, which someone brought into a recent repair cafe with a description that it was totally dead. I mentioned before that I volunteer as a repairer where people bring their faulty items, be it radios, toasters, vacuum cleaners, bicycles, chairs or even textiles, and we try to repair them at only parts cost. In this case, it looked as if the problem might need more time and tools than what was available on the day, so I agreed to take it home, hopefully fix it and return it on the next repair cafe. I had already taken the radio apart in the repair cafe, which is why it's in this state. We had also established that unplugging the power supply and instead feeding 12 volts DC from a bench power supply would make the radio work again. In other words, the problem is in the power supply. While I have all the kit at home, it so happens that I'm right in the middle of renovating and reorganizing my lab, so most of my equipment is unplugged and not readily available. Hence, it's all a bit improvised and you may spot paint residue on my hands. Here's the offending power supply. In the cafe we had already opened the black and yellow plastic around the center part to check for any obvious failed components. What was readily apparent was that the soldered-in fuse had blown, and we did not have such a type in our spares. It is rated T2A 250 volts, that is a slow 2 amp fuse. To enable testing, we fabricated a temporary replacement using a standard 20 by 5 mm long fuse of the correct rating, covered it with heat shrink and soldered it in place. Trying to power up blew that fuse again, which was when I decided to continue at home. This power supply is surprisingly spacious in its layout, but then there is lots of space inside the radio. It uses only a single layer PCB, but seems to be not too bad in its design. They did not skimp on interference suppression components, and there's even an inrush limiting NTC. Checking the DC output reveals no short circuit on this side. The meter indicates that the output filter capacitors are charging up, as you would expect. It seems very likely that the problem is on the high voltage side. I decided to start with a bridge rectifier made of 4 individual diodes. Sadly, the diodes are half covered by the glue they use to ensure that the choke and the large electrolytic cap are not moving, so the only way to measure is from the solder side. First one shows a typical forward voltage. Number 2 is shorted. Number 3 is open, which might be alright if I'm looking at the reverse direction. And number 4 another short. 2 are definitely faulty. Let's check again with the leads reversed. Number 2 is still shorted, and so is number 4. Number 3 that was reading open before now shows the correct forward voltage of about 0.5 volts, so that one is okay. How about the big capacitor? It is shorted as well, but that could be because of the faulty diodes. In parallel to the big capacitor is a small blue capacitor similar to the typical interference suppression caps, and I see it has a bit missing. It looks like it blew up. Interesting. The next step is desoldering the small blue capacitor for a closer inspection. Yes, it's certainly damaged, but surprisingly not shorted. The print on it is 103, in other words a 10 followed by 3 zeros or 10,000 picofarad or 10 nanofarad and 1 kilovolt or 1000 volts. No other text. Certainly it's not a safety class X capacitor. I decided to remove the big electrolytic cap just in case, even though that requires the tedious process of cutting away the glue holding it in place. With both caps out, 2 of the diodes are still shorted, so they have to go as well. Out of circuit, the big capacitor rated 47 microfarad 400 volts tests around 41.5 microfarad and an ESR of about 0.78 ohms. Those values are still acceptable. Good news, because I have no replacement with the same rating available. What about the one with the part blown off? Well, it's also not dead. 7.7 nanofarad instead of 10 nanofarad, but I don't think it would be advisable to reuse it. I have a 10 nanofarad cap rated for 3000 volts, which will replace it. I tested the old one for leakage, only using 30 volts, and amazingly, even with that low voltage, this damaged capacitor passes nearly 0.5 milliamps. With 370 volts DC or so in this power supply, it probably would be 5 milliamps and cause a dissipation of nearly 2 watts. Compare this with a new capacitor, which has a leakage current lower than the 10 microamps this vintage flue can measure. The two failed diodes are of the common 1N4007 type. I have plenty of those, so replacing them is very straightforward. The temp fuse we added in the repair cafe has blown, no wonder, since the primary side was essentially a short circuit. I could not find an exact match for the original soldered in fuse, which is 10 by 3 mm, and had to order a 20 by 5 mm type for solder in. Until it arrives, I added another temp in form of this fuse holder. At least that makes replacement easier if I blow another while testing. I connected the power supply via my light bulb current limiter to my variac. The left meter shows the DC at the primary side and the right the DC on the output. Ramping the AC voltage up to 120 volts shows about 176 volts rectified DC on the primary side and about 11 volts DC on the output. So far so good. Let's go all the way to slightly beyond 250 volts AC, rectified to about 360 volts, and the output remains at about 11 volts. This power supply is now working just fine. Finally, the replacement fuse arrived. As I said, it has the correct rating, but it's quite a bit larger. Like the original, I covered it in heat shrink to make it safe against accidental touch and mount it slanted so it doesn't stick out beyond the dimensions of the power supply. Running a quick test with the power supply plugged in directly to mains shows the power supply is still working as it should. It has been more than 2 weeks since I took the radio apart. I hope I still remember how it goes back together. There is this rail inside the radio and I thought that was for the power supply, but no, because I forgot to fix the cover on the thing, and with a cover there is no way it would fit into the rail. I vaguely recall there was another trick and empty all the capped screws to refresh my memory. Now I remember, it slots into 2 short rails on the rear panel. But the screws holding it there have to come from the inside, which is the tricky bit. I can sort of start the screws a bit slanted from the side, but the tightening needs a very long screwdriver that goes all the way from the front through the radio to reach the rear panel. Next, the antenna socket needs to be mounted on the rear panel, and the cover held on with 2 screws makes it pretty. Oh, silly me, I should have threaded the antenna itself in before fixing the cover. Oh well, off goes the cover, in the antenna, and put the cover back, hopefully for good this time. The rear panel itself is held with 2 sets of 4 screws. The round holes, by the way, are ports for the speakers, intended to improve the sound. The exact same patterns of 2 times 4 screws are replicated for the front panel. The white holes are for speaker covers that just plug into them. Let's see if everything works. Applying mains power and the display comes to life. Great. Time and date is always shown even when the radio itself is off, as in here, because it is intended as a bedside clock. It could be disturbing, which I believe is the reason that the owner put tape over the display. I had removed the tape when working on the radio, but the residue is still there. Anyway, since they will tape over the display again, I don't bother with cleaning. Turning the radio on, I found that FM works fine, but none of the preset DAB stations would work. Unfortunately, the buttons for auto-scanning the DAB band are only on the remote, which the owner did not bring, so FM is all I can test, and it works fine, and even picks up time and date from the received data. The owner provided a CD, so let's see if that works. I expected a tray to open, but apparently you just start putting the CD in and the player will take it and pull it in all the way. Well, it's reading, which is a good sign. And after quite a while, it does start playing the first track. Okay, CD is working as well. I don't have an iPod, so I can't test if the socket for it works, but I can test the 3.5mm aux input at the rear. It works fine, as you can hear, and this radio is ready to be returned at the next repair cafe. The items that failed are on display in front. I forgot to add the fuse, but to be true, the fuse did not fail. It did its job when these components failed. If you like my videos, don't forget to like and subscribe and help growing this channel. And consider becoming a Patreon. The link's in the description. Thanks for watching.